So for number one, what can you replace tangent with? Sine over cosine. It's a series of replacements, all right? So this is going to be negative sine over cosine. I'm going to leave the cosine there, but I usually write it over 1. And then what's going to happen? Yeah, they can't. That's the whole idea of writing it in sines and cosines. Now it comes out to negative sine, but which thing over here means that? B. I'm not going to scratch it off though, because these can get used more than once. On your test, they won't though. They will all match with something on your test. So you can use like process of elimination. This is one of the Pythagorean ones, secant squared minus 1. I wrote them on the board behind me. Those won't be up there when you take the test though, but secant squared minus 1 would give you what? Yeah, tangent squared. So that one is F. What can you replace secant with? We're going to do a replacement. 1 over cosine, big fraction bar. What can you replace cosecant with? 1 over sine. And so I'm going to multiply by the reciprocal. Oops. And nothing cancels. Well, I guess you could view it like the ones cancel, but you end up with sine over cosine, which is going to be tangent. So E for that one. How are we doing on the first three? I was listening to you guys. Sounds like you guys were talking your way through it. All right, whenever you see a squared, it means you're going to write it twice. So here's what I'm going to do because I don't have a lot of space. I'm just going to scribble out the squared and write this again. Then we're going to multiply it all together. You ready? Sine times sine. Sine squared, good. Now the outsides give you a minus sine cosine. The insides give you a minus sine cosine. So together that is minus 2 sine cosine, minus 2 of them. Now negatives cancel, so this will be plus negative times a negative. Cosine times cosine is cosine squared. Now I know that they're not right next to each other, but in there we do have a sine squared plus cosine squared. And again, I have them on the board behind me. Sine squared plus cosine squared equals 1. So which answer choice is this? You see it in there? L. 1 minus 2 sine cosine. All right, what can we replace cotangent with? Good, cosine over sine. I'm going to keep the sine in there, but I'm going to write it over 1. Sines cancel, that gives you cosine. So that one is C. Here we're going to distribute. When you do sine times cosecant, think of it this way. What could you replace cosecant with? 1 over sine. So if you have sine times 1 over sine, what happens there? What do you get when you multiply those? If you have sine times 1 over sine, it's just going to end up being 1. Like you just get 1 when you multiply this. Let's talk our way through this one. If you did cosine times secant, that would also just be 1. Tangent times cotangent, like they just cancel and you get 1. All right, minus sine times sine is sine squared. Again, I've got them on the board behind me. 1 minus sine squared is going to be what? Cosine squared. So D for that one. Again, I know that they're not right next to each other, but do you see how there's a sine squared plus cosine squared in there? That's going to give you 1. So this is 1 plus tangent squared. And again, I've got them behind me. 1 plus tangent squared is going to be what? Secant squared. So that is J. Is anybody 7 for 7 so far? Good. I heard you guys talking through it. It sounded like it was going well. All right, what can we replace cosecant with? 1 over sine. And what can we replace secant with? 1 over cosine. And then we can replace cotangent with cosine over sine. There's a lot of fractions in there, but you guys handled the ones like that well on your quiz. You did a good job on it. So I'm going to multiply by the reciprocal. I'm going to flip this over. It'll be sine over cosine. So we're going to look just at that part. What cancels? Does anything cancel there? Yeah, sines cancel. The cosines don't cancel because they are both in the denominator. So instead you multiply them together and you get 1 over cosine squared, which would be what? Secant squared. Good. So that is J. So again, you're able to use them more than once on here on your test. It won't be like that. All right, 1 over tangent squared. Let's see, I would replace that with cotangent squared. There's always different ways you can get through this. That's probably what I would do there. Plus, ooh, cotangent times tangent will cancel and just be 1. And then let's look up there, cotangent squared plus 1 cosecant squared. So that one's G. All right, this one, you want to view it like this. 4x squared plus x minus 3, and you do your factoring. It's just instead of x, it's tangent of x. All right, so we're going to draw our 2 parentheses. Looking at this one, how would you want to split up the 4? Would you want to do 1 times 4 or 2 times 2? Yeah, 1 and 4. It's just instead of 1x and 4x, it's 1 tangent x and 4 tangent x. Now, can you pick the choice already? Like, do you see where we're headed with this? Because it's matching. You guys see it on there? All right, but let's finish the problem anyway, just for the sake of being thorough. You would put 1 and 3 for your 3. The outsides give you 3 tangent x. The insides give you 4 tangent x. We want to have a positive 1 tangent x in the middle, so you would need a plus here and a minus here. It is just factoring like what you've done before, and that one's m. All right, I'm going to have to write this one over here because I ran out of space. What can we replace cotangent with? Good, cosine over sine. I'm just having to write over here because I ran out of space. We can replace secant with 1 over cosine, big fraction bar, and we can replace cosecant with 1 over sine. So same thing, I'm going to multiply by the reciprocal. I'm just going to flip this over. And then what cancels? Everything, right? All right, if the whole thing cancels, then what's our answer? 1. That one's A. All right, here we've got some of the negative ones. Well, this is just tangent x. I'm just going to keep that. Cosine, is that even or odd? Cosine's even, it turns positive. So it'll just be plus cosine x. And then good, this one's minus tangent of x. So what happens there? Yeah, tangents cancel, you just get cosine, which is C. Cool. I'm going to replace cotangent with cosine over sine, plus, and I'm going to replace tangent with sine over cosine. When you add and subtract fractions, you need a common denominator. So your common denominator is going to be sine cosine. You're just going to multiply them by each other, basically. Hang in there. We're almost done with this page. We'll do our break after this. Because the common mistake, there's people just cancel them and put 1. If you were multiplying, that would be the case, but we're adding. Now, this is personal preference. I always circle the numerator like, hey, all this stuff is going to go together. Cosine times cosine would give us cosine squared plus sine squared over our common denominator. So we put it all together. Go us. All right, what is cosine squared plus sine squared? What is that numerator? 1. Yeah, 1. And then you do these separately. 1 over cosine would be what? Secant. And 1 over sine would be cosecant. So that would be K for that one. All right, almost there. What are we going to replace cotangent with in this one? Cosine over sine. Cosine I'm going to leave alone. I'm just going to put it over 1. Anytime you don't change something, I just leave it over 1. And then what can you replace cosecant with? Good. You guys are on top of this. All right, what is that going to go together to be? The numerators will be cosine squared. The denominator will be sine squared. And what's that going to reduce down to? Yeah, good. Cosine over sine is cotangent. It's just squared. So cotangent squared. So that one is n. I'm going to save this one for last because it's actually horrible. It's like the worst one on there. This one's actually pretty easy though. When you have a 90 minus whatever, you either add a co or remove a co. So this one would be just tangent. Just remove the co and you get tangent. That one's E. I was actually going back through this one and thinking about how I was going to explain it. because there's a few different ways you can get through it. I think I'm going to just go with what do you guys notice, and I'll do it with whatever you guys notice first. Like, what would you try first in this? So sine over cosine, is that what you guys notice first? Okay, we'll do it that way because there's a couple different ways you can do it. What can you replace sine over cosine with? Tangent. And I'm going to have to come up here because I ran out of space. All right, so tangent. And then when you look at the second part of this, we did one like this in the notes. Do you see how this is 1 minus sine of x? You're going to multiply by 1 plus sine of x, which with the point being that some things are going to cancel. Does anyone remember what that's called when you have the opposite operation? It begins with a C. When you have 1 plus sign and 1 minus sign. Does anyone remember that vocabulary word? I'm just curious, throwing it out there. It begins with a C. Conjugate, good. All right, so we're going to have minus all of this. So minus cosine times 1 plus sine of x. Oops, it'll look like that. Sorry, I had to come back up there because I ran out of space. This is the last one on this side. Hang in there. All right, and then when you multiply that denominator together, 1 times 1 is 1. The outsides and insides cancel, which was like the whole point. And then minus sine times sine is sine squared. Okay, so it'll end up looking like that. You're probably like, how does that look better? It really doesn't. Oh, good. So you can replace this with cosine squared. And what I would actually do, instead of writing cosine squared, I would just write cosine twice. Do you see why I did that? Yeah, so it can cancel out. Thank you for coming with me. You guys didn't have a bad attitude about that at all. That problem is awful. All right, and then are we just about there? Can we pick an answer at this point? Does it look like any of these yet? Oh, did I do a copy error? Oh, there we go. Yeah, that's still not any of the answers though. Well, I see I have 1 over cosine. What's your reciprocal of cosine? Let me see if this, no, but see, that's not going to help us at all either. I forget what I did with, I worked this out earlier just to make sure I wasn't going to mess it up, and I still did. Okay, so I remember what I did here. I distributed the negative, so it becomes negative 1 over cosine. So what is 1 over cosine going to get replaced with? It gets replaced with secant, so we're going to have minus secant of x. And then if you distribute the negative over to here, we're distributing the negative through here, you get minus sine over cosine. So what can you replace sine over cosine with? Tangent. And then the last step there, what's going to cancel out? Yeah, the tangents cancel. You get negative secant, which, is that an answer? It is. Okay, H. There we go. Yeah, that one was super weird. All right, on the back here, I'm going to try and see what I can fit. I have a piece of scratch paper in case I need it. You're going to do algebra until you get the trig function by itself. Then you're going to make triangles and then put your answers. So what would you do first for this one? Add 4. All right, so we're going to get, if you write small enough, you might be able to make it fit. Let's see what happens. All right, then you have to get rid of the squared, which means square root. Now, when you put a square root, you have to put plus and minus. Now, my opinion is secant and cosecant are difficult. When I see those, I usually flip it. What's your reciprocal for secant? Bless you. Cosine. And if you reciprocate 2, you get 1/2. Oh my gosh, guys, 1/2 it's on the unit circle. Isn't that crazy? Now, I also like when it's plus minus because you don't have to worry about which quadrants you're in because it is all of them. And it looks like a little bow tie, which is just cute. So cosine is x. So your 1/2 goes right there. That means the other side, square root of 3 over 2. And you can just label one triangle. They're all the same triangle, just reflected over, right? And so what's your angle across from pi over 3 And then you're going to go around and get all of your answers that have pi over 3. So pi over 3, and then what's the one in the second quadrant? 2 pi over 3. We missed one. 4 pi over 3, 5 pi over 3. But hold on, can I answer a question over there? Did I lose you?
No, sorry, no.
Okay, no, I just wanted to make sure.
I thought you said.
Well, cosine is the x value, so 1/2 is the x value. That means this side is square root of 3 over 2. And so across from the square root of 3 over 2, you get pi over 3. All right, 18. First, you would subtract the 1. Also, do you see how this is x over 2? I like to write that as 1/2 x. That's my personal preference. You can, agree or disagree, whatever. It's a personal preference, all right? And then what's your next step? Divide by 2. So -1/2 is on the unit circle. Oh, I forgot my negative. And so now we need to figure out what quadrants we're in. Cosine is x, and that is negative. So what quadrants is cosine negative in? 2 and 3. So similar thing, the -1/2 is the x part of it. So that means the other side is square root of 3 over 2. And again, we get pi over 3. But this is one of those ones where it's not just x inside of there, it's 1/2 x. What does that tell us? It means you only go halfway around the circle. So you're not going to get this answer. You're only going to get one answer. So you didn't go far enough. Also, instead of x equals, it's 1/2 x equals. You get that extra step at the end where you have to get x by itself. So we have 1/2 x equals 2 pi over 3. And then your last step to get rid of the 1/2 is you're going to times by 2. So you get 4 pi over 3. I like the equations. I like them a lot better than the identities. Solving an equation is like familiar territory, and we can all draw triangles. Maybe we'll do every single one of these. I want to save some for you to practice. I don't want to do every single one. Maybe I'll skip like 1 or 2 here. Let's do 19. What would you do first to start doing the algebra part of that? Right. Subtract 1. Girls. All right, and then you would divide by square root of 3. Now that is not on the unit circle, but what you're going to do is put them both over 2, and then you have -1/2 over square root of 3 over 2. What's that? Yeah, you want to like unrationalize it. So if it was square root of 3 over 3, you would have to go backwards to 1 over square root of 3. But this one already was, so we were good. Oh, cotangent. So what quadrants is cotangent negative in? 2 and 4. I usually just remember tangent and cotangent go across from each other. If it's positive, it'll be in quadrant 1. So then also 3. And if it's negative, then it's the other 2. So cotangent is x over y. So that's how they're going to get placed. -1/2 is the x, square root of 3 over 2 is the y. So again, our angle is pi over 3. And how many times are we going around the circle? So how many total answers are we going to get? 6, because you're going to get 2 each time around. All right, so I'm going to go all the way over here and leave a lot of space. So 3x equals, all right, here we go. First one is 2/3. And then the one in the fourth quadrant is 5/3. Now you have to add a rotation, which is 2 pi. So that is 6/3. So if you add 6/3 to each of these, what are you going to get? 8/3 and 11/3. You're basically just adding 6 to each of the numerators because the denominator is 3. All right, now we got to go one more time. So you're going to add 6/3 to each of these ones. So it'll be 14 pi over 3 and 17 pi over 3. And I wouldn't give you more than that. Like the most answers I would give you is 6. If you get more than that, you have done goofed because I wouldn't do that to you. This is like the max I would do. Now you have to divide by 3. Now, if you've divided by 3 and then you divide by 3 again, you have now divided by 9. The only thing that's nice about that, and you're like, there's nothing nice about this and we hate you, is that 9 is not going to reduce with any of those. So you can kind of just mindlessly copy them all as ninths. It's going to be 2 ninths and 5 ninths and 8 ninths and so on and so forth. Yeah, so that's the only nice thing about ninths is none of them reduce. So just copy them all as ninths. Yeah, if you're like, how difficult will it get? That's about it. I wouldn't go further than that. I will save number 20 for you guys, because you should try something for next time. When I leave them blank, do you guys do those for next time? Like
I just like watched the
video. Okay. Well, I don't want to do them all. Like you study for math by doing problems. And if I do them all for you, then there's nothing left for you to try. So, all right. This one, we're going to factor, just like we did that one on the other side. You want to think of it as 4x squared minus 4x plus 1. It's a trinomial. It's just instead of x, it's cosine x. So how would you split up 4? What multiplies to be 4? I think in this case, we are going to want 2 and 2. So 2 cosine x, 2 cosine x. And then 1 be 1 and 1. And then do we want pluses and minuses, one of each, both the same? What do we want? Well, we want a -4 in the middle, so they're both going to be negative. And that's actually good. Why is that a good thing? Like convenient for us? They're the same thing. So you don't have to do 2 separate problems. You can just do 1 problem instead of 2. Because if they were different, you'd have to do both of them. All right. So let's just solve this one. What would you do to both sides? Add 1. Can I combine 2 steps? You would add 1 and then divide by 2. I think you guys can handle that. Cosine is x. What quadrants is your x value positive in? Yeah, 1 and 4. Actually, I made this one the same. If the 1/2 is the x value, the y value is square root of 3 over 2. I made these all pi over 3. Geez, sorry. You know the only other options are pi over 4 and pi over 6 though, right? Like, we don't have a lot of choices. All right, and so we get x equals pi over 3. And what's the one in the 4th quadrant? Good, 5 pi over 3. Perfect. All right, let's see. This one involves factoring too. So I'll do this one and maybe I'll skip these 2. All right, do you see how they both have, or actually I'll ask you, what do they both have in them? Sine of x. So it's GCF, it's greatest common factor. You're going to factor out the sine of x. So what's left once you take that out? Tangent x plus, oh good, 1. Now this is a double problem. You're going to set sine of x equal to 0, and you're going to set tangent of x plus 1 equal to 0. You're going to do both of these, all right? So sine of x equals 0. That's not going to be a triangle. That's going to be a circle. Using words like up, down, left, right, where is your y value 0? We want sine to be 0. Yep, left and right, good. So sine is y value, that's where your y value is 0. So what are those 2 answers? Yep, 0 pi and 1 pi. Now, when you go to do the other half of that, you would subtract over the 1, and that one is really tricky because it makes you think of the circle. But when it's tangent or cotangent, it's not. You're still going to get triangles. So where is tangent negative? What quadrants is tangent negative in? 2 and 4 and go across from each other. And what are the sides so that you end up with 1? In this case, -1, but what would the sides have to be? Yeah, good. Anything is itself over, like anything over itself is 1. Sorry, I can't talk. And so what does that mean your angle is? Pi over 4. Cool, I made one not come out to pi over 3. So 2 answers for that. In the second quadrant, that would be 3 pi over 4. And then in the 4th quadrant, 7 pi over 4, good. So how many total answers did we get for that question? 4, because we got 2 here and 2 here. Good. All right, let's come down to the ones that say solve for all solutions. That means going around the circle, around and around and around and around forever and ever and ever. So you're gonna have the plus whatever n, okay? We'll do these 3. What would you do first in this one to get rid of the squared? Now the square root of 1 is 1, but you have to put plus and minus. Don't forget the plus and minus when you do a square root. So that is going to be all the quadrants. And actually same as the one we just did, only cotangent instead of tangent, but same thing. The way you end up with 1 is with your square root of 2 over 2 triangle. I drew that really awful and that is absolutely going to bother me. So I'm going to fix that. I'm sorry. It just looked really bad. Is anybody else like that? Where are my type A people? There we go. That's better. All right. So what is our angle? It's pi over 4. Now this only works if it's pi over 4. We don't ever draw these to scale. We're just like, you know, I'm not getting out a protractor and measuring it, but this will not work for pi over 6 or pi over 3. The reason it works for pi over 4 is because they are evenly spaced exactly in the center here. So you can write your answer just one way, pi over 4 plus, now how far do you have to go to get to the next answer? It's only a quarter of the way around the circle. Pi over 2 n, good. If you go the whole way around, it's 2 pi n. If you go halfway around, it's, what's halfway around? Pi n. And then this is the one special case this works for. This will not work for any other angle. All right. I'll leave that one for you guys. Let's go down to 27. All right, for that one, you would add 1 and then, I'm going to combine the steps because I'm almost out of room. You would add 1 and then divide by 3. Good. So you add 1, divide by 3, and then square root. So you're going to need to put plus and minus. Square root of 1, 1. Square root of 3 is square root of 3. And then put the 2's in there. We got another plus minus. That means all the quadrants. So tangent is y over x. So 1/2 is the y. Square root of 3 over 2 would be this part. I ran out of space. I can't fit that in there. But what's important is the angle. What goes across from the 1/2? Good, I put a 6th in there. Pi over 6. Yay, we finally got a pi over 6. Now you cannot do the same thing we did here. These are not evenly spaced. You're, instead of being able to write one answer like this, you're going to have to write 2 because they are not evenly spaced. So you start with the first one, which is just pi over 6. And then how far do you have to go to get to this one? Do you see the one I'm highlighting? Pi, you go halfway around the circle. So plus pi n. So that takes care of quadrant 1 and quadrant 3 forever and ever and ever. Because if you add pi, you land here. And if you add pi, you land here. And if you add pi, you land. Do you guys understand what I'm saying? Okay. Then how would you do the other one? You have to take care of these 2. So it would be 5 pi over 6 plus pi n. Good. If I feel like people didn't understand me, I just keep on talking. And you guys are so quiet. I just keep explaining and explaining. Like, if you guys got it. So I can never tell. All right, and then we'll do this one. What would you do first? You would subtract square root of 3 and then divide by 2. Oh yeah, you're right. Good. I'm glad I put a few of each. Like, I didn't want them all to come out to pi over 3. All right, what quadrants is cosine negative in? Cosine is x. 2 and 3. Good. So this part, I'm not going to have room to write. I mean, I guess I can kind of fit it in there. It's just like super tiny. That's your negative square root of 3 over 2. That means this side is 1/2. And so your angle is pi over 6. Now, you're going to have to write these as 2 separate answers. You can't put it all together. So it's not evenly spaced the entire way around. The only way that works is with this, the special case with the pi over 4. Right? So what is your answer in the second quadrant? Yeah, now watch me point to this. You have to go the whole way around to land there again. So it's going to be plus 2 pi n. And then the other one, it's 7 pi over 6. Good. And again, you have to go the whole way around to land there again. The only time you're going to have that plus pi n is when you get like the plus minus and you have it in all 4 quadrants.